One of the most captivating cosmic phenomena is the possible supernova of Betelgeuse, situated in the well-known shoulder of the star grouping Orion. Betelgeuse is a crimson supergiant nearing the conclusion of its life cycle. Unexpectedly, in 2019, one of the most luminous stars in the heavens began to dim noticeably, discernible even to the unaided eye. For several months, its radiance diminished to such an extent that numerous watchers speculated whether the star was perishing. Aiming their telescopes at the massive star, researchers were amazed by proof of the significant dimming. Betelgeuse is thought to be on the verge of erupting into a supernova, signaling the conclusion of its stellar existence. But when and why will this cosmic detonation transpire? Could it pose catastrophic impacts for our planet? The radiant scarlet star Betelgeuse is positioned on the upper right shoulder of Orion the Hunter. You might know it by its alternate title, Alpha Orionis. Even though it is the second most luminous star in that constellation, following the supergiant Rigel, it continues to intrigue scientists due to its fluctuating behavior and distinctive moniker. Alpha stars are generally the brightest within their constellations, and although Rigel surpasses it in brightness, Betelgeuse draws attention due to its enormous size and reddish hue. Betelgeuse, also referred to as Alpha Orionis, ranks among the most renowned stars in the night sky, being the 10th most brilliant and 7th most visible for much of North America, Europe, and Canada. Its designation is derived from Arabic and signifies the armpit of the giant, referencing its spot in the star grouping. Betelgeuse sheds approximately 1 solar mass every 10,000 years, releasing substances uniformly in all directions and generating a nebula surrounding it. This nebula spans 30 astronomical units, or 30 times the stretch between Earth and the Sun, and is 250 times more massive than the star itself. At its heart, Betelgeuse's hydrogen nuclei merge under immense gravitational pressure, creating helium and emitting radiation and warmth. As the star depletes its hydrogen, it starts fusing helium and carbon as substitutes. When helium runs out, neon combines with carbon to yield iron. The merging of iron fails to produce energy, leading the star to cave in under its own gravity and ultimately burst into a supernova, among the universe's most forceful explosions. Depending on age and developmental phase, stars emit illumination in varied wavelengths, from the vivid blue of youthful stars to the red of elder ones. Based on the ancient stargazer Ptolemy, Betelgeuse exhibited a hue he intriguingly labeled as ruddy. Nevertheless, early Chinese astronomers remarked that Betelgeuse looked yellow, hinting that it may once have been a yellow supergiant. Massive stars rapidly burn through their hydrogen, leading to an early demise, even if their existence spans only 10 million years. There's no question that Betelgeuse is in its concluding phase. While our Sun still possesses more than 5 billion years of life, Betelgeuse is approaching its final moments, meaning it could someday erupt in a supernova. However, the precise schedule of this occurrence is still unknown. Betelgeuse experiences 2 cycles of brightening and fading, one happening every 5 years and persisting for around 100 days. It's assumed that the swelling and shrinking of its outer layers during these rhythms prompt alterations in its diameter and typical surface temperature. Widespread interest in Betelgeuse grew during its unpredictable conduct in 2019 and 2020, when its light faded dramatically before recovering briefly. Certain scientists have theorized that this strange activity could indicate the star is nearing its final transformation. Comprehensive analysis of Betelgeuse dates back to the 1st century BC, yet the origin of its dimming remains an absolute enigma. Betelgeuse has been spotted moving through the interstellar environment at about 30 km per second after being thrown from its birthplace in the Orion OB1 group, which houses the stars of Orion's belt. The resulting bow shock extends beyond 4 light-years. Measuring the proximity of red supergiant stars like Betelgeuse is an infamously difficult job in astrophysics, as various elements hinder accurate diameter estimates. Moreover, since it's a pulsating star, Betelgeuse's size varies over time. This characteristic, alongside the dimming of its outer edge, causes its observed glow to shift in color and diminish as we view it further from its core. Additionally, the shell of material expelled by the star plays a vital part in light emission and absorption, also affecting how we interpret its brilliance. Directly contrasting views of Betelgeuse is challenging, since its visible size changes with the wavelength observed. These measurements can change by up to 35% based on the part of the light spectrum employed. In July 2009, the European Southern Observatory released visuals taken with a Very Large Telescope, VLT, interferometer on its ground-based observatory, revealing a massive plume of gas stretching up to 30 astronomical units from the star's surface, one of many mass expulsions seen from Betelgeuse. This outflow matched the angular distance between the Sun and Neptune. At least 6 such events have been found around Betelgeuse. These repeated mass expulsions contribute to the complexity of Betelgeuse's outer atmosphere and its surrounding nebula. Each eruption releases vast amounts of gas and dust into space, altering the star's brightness and further obscuring accurate observations. Astronomers speculate that these ejections could be linked to convective currents deep within the star, hot bubbles of plasma rising to the surface and disrupting the equilibrium of its outer layers. In early 2020, NASA's Hubble Space Telescope detected evidence that the 2019 dimming event was likely caused by a massive surface mass ejection, unprecedented in its scale. This ejected material formed a dust cloud that temporarily blocked light from the star, making it appear significantly dimmer from Earth. Such an event is similar to solar ejections from our Sun, but on a much grander scale. This discovery brought a renewed focus to the unpredictable behavior of red supergiants and the stages leading to their eventual collapse. Researchers are closely monitoring Betelgeuse for further anomalies, using both ground-based and space-based telescopes. Understanding these irregularities could provide a rare glimpse into the final years, perhaps even days, of a massive star's life. Despite the drama surrounding its variability, Betelgeuse is not expected to go supernova imminently. While the idea of witnessing such an event within our lifetime is tantalizing, current models suggest that the explosion may still be tens of thousands, or even hundreds of thousands, of years away. Nevertheless, because of its relative proximity to Earth, approximately 642 light-years away, a Betelgeuse supernova would be an extraordinary astronomical event. If and when it occurs, the supernova would not pose a threat to life on Earth due to its distance. However, it would outshine the full moon in our night sky and be visible even during the day for weeks or months. It would also offer an unprecedented opportunity for scientists to observe a supernova in real time and gain insight into the death throes of massive stars. The story of Betelgeuse continues to captivate astronomers, astrophysicists, and stargazers alike. With every pulse, flicker, and flare, the crimson giant reminds us of the grandeur and unpredictability of the cosmos. As humanity's gaze remains fixed upon Orion's shoulder, we are left to wonder, will we be the generation that witnesses a star's spectacular farewell? Occurrences might reveal clues to the question of mass ejection in the concluding periods of massive stars, which may be central to their destruction. The complicated processes within Betelgeuse's extended upper layers remain puzzling, as does the exact method by which red supergiants cast off their matter. Such stars are fundamental to the circulation of elements within galaxies, and due to progress in interferometry, astronomers are approaching solutions to these riddles. In 2019, scientists employing the Hubble Space Telescope and other observatories found that Betelgeuse had blown off a considerable portion of its outer shell, triggering a substantial surface mass expulsion, SME. Though the Sun creates solar mass ejections, Betelgeuse's events were thousands of times more extreme, with this theme flinging out material 400 billion times the mass of a typical solar eruption. This accounts for why Betelgeuse suffered a steep drop in luminosity in October 2019. By mid-February 2020, it had lost nearly 3 times its brightness, shifting from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had stayed largely constant for more than a week. On the 5th, it looked like the dimming had stopped entirely. However, the recent reductions in visible light weren't connected to a probable core collapse, as no notable changes in infrared radiation were registered on February 24, 2020. Feel free to share your thoughts in the comment area. If you appreciated this video, click the thumbs up icon and subscribe so you won't miss future content like this. When Betelgeuse ultimately detonates as a supernova, it will be among the most dramatic cosmic occurrences ever documented. Even at a distance of 640 light-years, the blast will be so radiant that it could outshine the full moon and even be seen during daylight for several weeks or even months. Experts estimate that the supernova will discharge more energy in mere seconds than our Sun will emit throughout its entire 10 billion-year lifespan. The illumination from the explosion will speed through space and eventually reach Earth as a brilliant pinpoint of light unlike anything we've witnessed before. But rest assured, we are entirely safe. Although a supernova that near may sound threatening, Betelgeuse remains distant enough that the detonation will not harm Earth's biosphere or living beings. What it will do is present an extraordinary scientific occasion. As of the last few years, Betelgeuse has returned to typical brightness levels, but its irregular dimming patterns are still under intense observation. Scientists are leveraging tools like the James Webb Space Telescope, the Hubble Space Telescope, and land-based interferometers such as the VLT and ALMA. They are tracking surface light fluctuations, patterns in convective activity, and continual mass outflows that seem to reflect the star's instability. One well-supported idea is that Betelgeuse's significant fading was brought on by a vast cloud of star-borne dust created during one such eruption, momentarily veiling the star's light from our viewpoint. Grasping the mechanisms behind Betelgeuse could assist astronomers in decoding the life phases of gigantic stars, particularly those close to undergoing supernova. Such insights could help forecast similar phenomena in other galaxies, explain how chemical elements enrich the cosmos, and detail the formation and scattering of elements like iron and gold throughout space. Betelgeuse is effectively a ticking cosmic timepiece, and it's winding down slowly. It may explode tomorrow, next year, or in 100,000 years. But whenever it does, it will present a galactic spectacle and a wealth of scientific data unmatched in modern times. In preparation for Betelgeuse's eventual supernova, astronomers worldwide are collaborating across observatories, nations, and technologies to ensure no detail is missed. Space-based instruments monitor its infrared and ultraviolet emissions, while ground-based telescopes capture shifts in spectral lines, surface granulation, and velocity patterns within the star's photosphere. These efforts aren't merely academic. By understanding Betelgeuse's decline, scientists hope to unlock early warning signs for other stars on the brink of collapse. Identifying pre-supernova behavior could give humanity a valuable predictive tool, allowing us to catch these rare cosmic events in real time and observe every phase, from core implosion to shockwave expansion. Betelgeuse's story is also a lesson in humility and awe. Despite centuries of observation and our rapidly advancing technology, the cosmos still guards many secrets. This massive red supergiant, easily visible to the naked eye from Earth, continues to baffle experts with its irregularities and sudden shifts. And yet, this mystery is precisely what drives astronomical research forward. In pursuing answers about Betelgeuse, we not only gain insight into the lives of stars but also into the very origins of the elements that make up our world. Every atom of oxygen we breathe, every molecule of calcium in our bones, and every trace of iron in our blood was forged in the heart of a star, not unlike Betelgeuse, before being hurled into the galaxy by explosions just as dramatic. As we stand beneath the night sky and glance at the constellation Orion, Betelgeuse stares back as a glowing emblem of both creation and destruction, a cosmic countdown that connects us to the ancient processes of the universe. Its eventual supernova will not mark an end, but a transformation, one that will ripple across the heavens, beaming light, matter, and knowledge into the farthest corners of the cosmos, and into the minds of those who are watching, waiting, and wondering.